In this beginner Power BI tutorial, we will cover how to install and navigate the new Power BI interface, how to import your data into Power BI and transform and clean up your data, how to write and understand DAX, the real analytical power of the BI, and we will do all that whilst building this report here. To build a strong foundation and understanding of Power BI, I would suggest that you watch this video from the start and try not to skip sections, as each section will help you build your understanding for the next. If this sounds good to you, grab yourself a coffee or tea or pizza and enjoy the video. The story around your data. Miss M's Perfect Pizza has pizza locations around the world, and they're thinking of expanding, but they're not sure which of their pizzas are the most profitable or which of the 4 locations have been performing the best. They've given you their sales data for the last 3 years and asked that you provide answers to these questions. Which year had the highest profit margin? Which pizza had the highest sales value in all 3 years? Which location had the highest margin percentage over the entire 3 years? And can you build them a report that they can use to analyze their data on an ongoing basis? You've decided to use Power BI to help you with the analysis and to build the report. The first thing you'll need to do is open up your Microsoft Store and search for Power BI Desktop. And you can click on Install. Once it's installed, you can open it up and you'll be greeted by this screen. It shows you a menu of what's new in Power BI, forums, Power BI blog, and tutorials. If you want, you can uncheck Show the screen on startup, but we'll leave this as it is for now. If you have an account, you can sign in. If you don't, that's fine, as you can use Power BI Desktop for free without signing in. But if you want to share your dashboards and reports with other users so that they can view and interact with your reports, then you'll need to sign in. As I've already signed in, I'm going to exit this window. This is your Power BI interface. It's similar to Excel, with your ribbon at the top, but in addition, there are these extra panes on the left and on the right. On the left here are your view types. The first icon is for your reports. This is where you will be creating your visuals. The second icon is your data view. This is where you can view your data in a table or a column, and it's useful for when you want to inspect your data right down to the row level. And the third icon is for your model. This is where you can create relationships between multiple sources and multiple tables. On the right here is the report editor panes, consisting of filters, visualizations, and fields. We will get into more detail on these panes as we create our reports. But basically, the filters and visualizations control what your reports and dashboards look like. So the type of charts, the colors, filters, and formatting. The fields pane is where you'll find the field names of your data that will be used in your visualizations. We haven't yet imported our data, so this is blank for now. Then the section in the middle here is your report canvas. This is where your reports and dashboards will be displayed. So whatever you select in these 3 panes will be displayed here in your report canvas. You can import your data from Excel or from SQL Server, or we can directly copy and paste our data into a blank table, or we can use a sample dataset provided by Power BI. You can also click on the Get Data function here to connect to your data sources. And if you click on More, you can see all the different data sources that you can connect to. I think Power BI supports more than 160 data sources. We're going to upload from Excel, so let's click on Import Data from Excel, and let's select our sales data workbook. This navigator window pops up, and here we can see our sales data table and transaction sheet in our workbook. Let's select our sales data table, as this is best practice. And on the right here, we get a view of our sales data transactions. We have the date of transaction, the product ID, quantity sold, and the location of the pizza shop making those sales. We can either load the data or transform it. We want to do some transformations, so let's select Transform Data. And we've imported our data into our Power Query editor. This editor is within our Power BI application. and it's where we can clean up and transform our data. I have one more set of data to import into our Power Query editor. So let's right-click on the pane on the left here and go to New Query and select Excel Workbook, and let's double-click on Product List. So each time we import data into Power Query, this navigator window pops up. Let's select our Product List table, and on the right we can see what our table contains, which is our product code of our pizzas, the name of our pizzas, the price, the cost, and the product range. Let's click on OK, and we've imported our product list data into our editor. If we look at our data, our product code column in the product list table is the same as our product ID column in our sales data table. This will be crucial in creating our data model, but we will get to that in a few minutes. But first, we need to create a calendar table. A calendar table will allow you to filter your reports by attributes like year, month, and any other aggregation of time that you require. And you can use it across as many data tables as you need. So it's definitely a must. You can create your calendar table in Power BI or Power Query, but let's do it here in Power Query. To create your calendar table, let's right-click on the sales data query and click on Reference so that we can create a query that references our sales data query. So if any changes are made in our sales data query, it will automatically update the second query here. Let's call this query Calendar Table. Next, let's right-click on the Date column and select Remove Other Columns. And we're only left with our date column, as this is the only column that we need. Next, right-click on the date column again and select Remove Duplicates, as our calendar table cannot have duplicates. You will notice that the steps are being recorded on the right here. This is where Power Query automates the process if any future files need to be added to this data. If the query editor is new to you, I highly recommend you watch this video here, where I show you lots more data cleanups and transformations like splitting and merging columns, cleaning up data inconsistencies, when to use the functions in the Transform tab, and when to use the Add Column tab, and so many other transformations. So definitely check out this video after this. Next, with our date column selected, let's click on the Add Column tab, and go to Date, go to Year, and select Year. And let's do that again. Select our Date column, go to Date, Month, and select Month. And we get our month number. And let's do that one more time, but this time let's select Name of Month. Let's double click on the column header for month and call this Month Number, and hit Enter. Now we're done in the query editor, so let's click on File and click on Close and Apply. And we're back here in Power BI. If there are more transformations that you want to do later on, you can go back to your query editor here in the Transform Data tab. But let's close this. And if you click on the Data tab on the left here, you will find your data with the changes that you made in Power Query. And on the right here are our 3 tables. And if we click on one of our tables, we have the column names for that table. When we click on one of these column names, the column is selected in our table on the left here. If a column has numbers, Power BI will add the sigma icon, which means the column can be summarized. But this is our month number column, so we don't want this to be summarized. So to change this, here in your ribbon, under Column Tools, you have Summarization. Let's click on the drop-down and select Don't Summarize. And the sigma icon has disappeared. We can do the same for Year. Next, we're going to create our data model. To do this, click on the model icon on the left here, and we can see all 3 tables here. Data modeling is where you will connect different tables by creating relationships between them, and you will connect them by using common columns in each table. For effective data modeling, it's important to note that tables are categorized into 2 types: dimension tables, which we will refer to as lookup tables, and fact tables. A fact table is the actual data that you want to analyze, and the lookup table is like a dictionary that provides context and meaning to the data that you're analyzing. Your lookup tables should have unique columns in them, as these are the columns that will be used in slicing and dicing your fact tables. If the column headings are the same across tables, then Power BI auto-detects the relationship between our tables. If we hover over this relationship line, we can see that Power BI correctly detected the relationship between our product code column in the product list table and the product ID column in our sales data table. We don't have a relationship created yet for our calendar table, but that's fine, we can create that. But before we get to that, let's make some sense of these tables. As mentioned before, in data modeling, we get our fact table and lookup tables. The fact table is basically the data that needs to be analyzed. It's your transactional data. In this model, our sales data table is our fact table. Then the lookup tables will be our calendar table and product list table. These two lookup tables will help us to filter the fact table. Let's drag our sales data table down here and keep our lookup tables at the top. We can visualize that the columns we select at the top here filter the transactional data down here. The relationship between our product list table and sales data table shows a one-to-many. The asterisk means that this is the many side. So each product code in our product list table, which is the one in the relationship, can have many transactions with the same product code in our sales data table, because you can sell the same pizza many times. And the same logic applies for the relationship between our calendar table and sales data table. On any specific day, we can make lots of pizza sales. So our calendar is the one side and the sales data the many side of the relationship. Remember, we removed duplicates in our Power Query editor when we created this calendar. So let's drag date from our calendar table to date in our sales data table. And we've created a one-to-many relationship. If a relationship is incorrect, you can right-click on the relationship line and select delete. Now let's go back to our data tab, and if we click through our tables on the right here, we will notice that we don't actually have any information on the margins. Remember, our analysis had quite a few questions relating to margins on our pizza. And to get these insights, we need to use data analysis expressions, aka DAX. It's a formula language that was created for working with relational data in Power BI and Power Pivot. DAX is the real analytical power that sits behind Power BI, and once you can master it, your analytical possibilities will be endless. To learn DAX, you first need to learn how to build a calculated column. A calculated column is a column that you add to an existing table and use DAX to calculate the column's values. The calculation is done row by row, and this is what's called a row context. What's a row context? First, let's understand what we mean by context. Context is basically the data set that is being used at a given moment. So here in our sales data table, if we were to calculate the margin in this row, the context or data set would be referred to as the row context. But if we wanted to only see the margins for the locations in, let's say, London, then we're changing the context or our data set from just the specific row to instead a dataset that's only based on London, and that's referred to as a filter context. So if we had this table in Excel, we would just add a filter and select London, and we would get our filter context. But to get the same result in Power BI, we will need to use measures in DAX. But first, let's learn how to create our calculated columns. We're going to create 4 calculations here in our sales data table. First, let's calculate our sales value. In the Table Tools tab, click on New Column, and a new column is added to our table. Here in the formula bar is where we will create our calculation. In Excel, you start off your calculation with the equal sign, but in DAX, you start off by giving your calculation a name. Let's call this sales value, and then the name is followed by an equal sign. We know that our sales value would be our quantity sold multiplied by our price per unit. So let's start typing quantity, and our table sales data with the column name quantity sold comes up. So let's select that. Just to note, when we're performing calculations in Excel, we reference a cell like A1 or a range like B1 to B10. But in DAX, we reference columns or tables, and column names are always in square brackets. Next, let's insert the multiplication sign, and let's start typing price, but the column that we require, price per unit, doesn't show up in our IntelliSense. This is because it's in a different table. It's here in our product list table. So we need a function like VLOOKUP to help us look up the prices in the related product list table. And in DAX, that function is called related. So let's remove price and let's type related, and the IntelliSense brings it up so we can select that. And automatically all the columns that we have on the one side of our relationship comes up. Remember, our calendar table and product list table were on the one side in the data model, and our sales data table was on the many side. So the related function fetches the value from another table based on the existing relationships in your model. It goes through a one-to-many relationship. It grabs the value from the one side of the relationship and brings it to the many side. So let's select product list price per unit and insert the close brackets and hit enter, and we get our sales value calculation. Now let's calculate our cost of sales. We'll follow the same process. In the Table Tools tab, click on New Column, and let's call this new column COS for cost of sales, and type the equals, and let's start typing quantity, and the IntelliSense brings up our sales data table with the quantity sold column, so let's select that, times, and let's type related, and the IntelliSense brings it up. Remember, we need to use related as our cost per unit is in a related table, so let's select product list cost per unit and insert the close brackets and hit enter, and we get our cost of sales. Next, let's calculate our margin. Insert a new column and let's call it margin equals, and let's type sales value, and our sales data table with the sales value column comes up, so let's select that and insert a minus and type COS, and we get our sales data table with the cost of sales column, so select that and hit enter. As both these columns are in the same table, we didn't need to use the related function. And lastly, let's add one more column and calculate our margin percentage, which is simply our margin divided by our sales value. For this calculation, we're going to use the divide function instead of the divide operator, as the divide function will return blanks in instances where our denominator is 0. Our numerator is our margin, so it's sales data margin, insert a comma, and our denominator is our sales value. And it's our sales data table with sales value as the column, so we can select that, insert a close bracket and hit enter. And we have our margin percentages. Let's change our format to a percentage, and let's change our number of decimals to 0. So we now know the basics of creating DAX formulas when we use calculated columns. But now we can see that the values from a calculated column are created for each row as soon as the formula is entered. So this means that the values are stored in the memory data model. So when you start adding more and more calculated columns, this will not be ideal, as this will use up space, and as a result, slow down your query. This is where measures come in. Measures are similar to calculated columns, but they are created outside of a table and can be used in multiple tables and visualizations. So they do not belong to any specific table, as they're only calculated when you need them. Let me show you what I mean. Let's calculate our sales value as a measure. To create a new measure, in the Table Tools tab, click on New Measure. Notice that a new column was not added to our sales data table, but instead it was added as a field here in the data section of our sales data table. So we will create our measure here in the formula bar. Let's call this measure M sales value so that we can easily distinguish between our measure and calculated columns. You can also determine which is a measure and calculated column by the icons. So a calculated column is this column with a sigma sign, and a measure is a calculator icon. But for the purposes of this video, I'm going to add the letter M. No, not for Miss Microsoft, but for measure. Just a quick tip. If you need to zoom in and out of your measure, you can click on the formula bar and hold down the Control key and scroll up or down with your mouse to zoom in or out. Let's insert the equal sign and start typing quantity sold, and we would expect the IntelliSense to come up with our table and column names, but it doesn't. Instead, quantity is grayed out. This is because we're trying to use a row context in a measure. Let's go back to our sales value calculation that we created using a calculated column. The syntax for calculated columns is our column name equals, and then it's our table name followed by the column name. So this is the syntax for a row filter, which can only be used in a calculated column. So then what do we use in a measure? Because we know that we need these exact column names in these tables to calculate our sales value. When we're creating a measure where the calculations are based on existing columns in a table, we need our calculation to move row by row in our table. So it needs to calculate for each row quantity sold multiplied by the price column from our product list table. So we still need this section of our formula in our measure. So let's copy this section of code and go back to our M sales value measure, and let's paste it here in our formula bar. Notice our column names are still grayed out, as Power BI knows that we're creating a measure, and this syntax here is for a row context. And a row context is not possible in a measure. It's only possible in a calculated column. See, the BI developers at Microsoft had a meeting to discuss the best way possible to ensure that our reports and dashboards were created in the most optimized way possible, where our storage and memory would be used as little as possible. And that's where measures come in. Measures are dynamic formulas where the results change depending on the context that we used. So in that BI developer meeting, they decided that instead of storing the values from each row's calculations in our table, a better way would be to not have the results of our calculation immediately produced anywhere. They decided that when we give our formula context, then only will the results be produced. So a calculated column will calculate each row's value and you will immediately see the results in your table. But a measure will calculate the sales value for each row, which is quantity sold times price, and once Power BI gets each row's values, it sums it up, if that's what you tell it to do. You could also tell it to calculate the average or min or max or more, and when you tell Power BI, you want to see the sales value for, let's say, each location or for a specific time frame, then only will you see the results of that calculation. So essentially, you'll only see the results of your measure when you use filters or slices. And this is what the developers decided to call filter context. When we give our measure context, then only will we see the results. And of course, this solves the problem of using up space in our reports. So let's get back to our sales value measure. We're calculating our quantity sold by our price. And now we need to determine what do we want our filters to be based on. Well, if we had to select a filter based on location, then we want the summed up value for, let's say, London. And the same logic would apply if we wanted our filter based on a specific time frame. We would want the summed up value for a specific month or year, for example. So let's type SUM here before our formula, and then IntelliSense brings it up. But our column names are still grayed out. Let's look at what SUM requires. It shows that it only accepts a column reference as an argument. So it only accepts column names and not tables or expressions. So this is where iterating functions come in. These are the functions with the X at the end of it. The X stands for expression. So let's type SUMX here. And the first argument that it requires is a table. This is the table containing the rows for which the expression will be evaluated. So let's type sales data for our table and insert a comma. And this is the expression that will be evaluated for each row in our sales data table. And we can press enter, and our error has disappeared. And here on the right is where we will see our sales value measure. But as mentioned before, it will not physically show up in our sales data table. So let's see how it will show up. Let's go to our report canvas and let's expand our visualizations pane. And here in the build visual tab, let's select the table visual and it gets added to our report canvas. To populate this visual, we will need to add fields from here in our fields pane. When we expand the fields pane, we can see our tables from our data model. Let's expand sales data and let's drag and drop sales value to columns. Remember, sales value was our calculated column. And now let's add our sales value measure. That's the measure that starts with the letter M. So we get these two columns in our table that we can compare. Both values are the same, so that's a great start. Now let's add a column that shows our sales value by location. Location is here in our sales data table. So let's drag and drop that here. And we've changed our context from showing us only the summed up value of our measure to now showing us our measure in the context of location. So this is how filter context works. We did not see the results of our measure until we visualized it here in our report canvas. So measures can only be seen when we give them context. So just to recap, a calculated column is a column that you add to an existing table and then create a DAX formula that calculates the column's values. The values in a calculated column are calculated for each row as soon as the formula is entered. These values are then stored in the memory of your data model. Calculated columns use the row context, meaning the calculation is based on the specific row where the calculation is being performed. As calculated columns belong to a specific table, you need to specify the table name, then the column name in square brackets. If the column that you need to use is in a different table, related can be used as your VLOOKUP. Then, as normal, specify the table name and column name in square brackets. A measure is a dynamic calculation using DAX, and it does not exist in a table. The values for a measure are not immediately output anywhere. The values will only be determined when we give the measure context. As measure values are calculated on the fly, they are not stored in the memory of your data model. Measures use filter context, as we mentioned in point 8. The values will only be determined when we give the measure context. Let's create the rest of our measures. Click on New Measure. Notice that we're creating this in our report canvas and not in the data view. That's because you can create your measure or add a new column in any of these three view types. So you can even add a new measure here in your model view. The column or measure will be added to the table that you have selected. But let's go back to our report view, as I prefer this view for now. You can use the data view or the model view if you prefer. Let's call this new measure MCOS for cost of sales, and the M is to show us this is a measure, and insert the equal sign. We could just copy the formula from our cost of sales calculated column, but let's rather write this from scratch. But before we get to that, 80% of my viewers are still not subscribed. If you're getting value from this video, I would really appreciate it if you could please hit the subscribe button, as this will really help me hit my 2023 goal of attaining 50,000 subscribers. I know that we can do it. Now let's get back to our video. Let's use the SUMX function as our iterating function. And we know that if we're using columns from a table to calculate our measure, we need to use iterating functions. And iterating functions also allow us to use expressions in our calculation. The first argument is the table that our function will iterate over. So let's type sales data and insert a comma. Then for our expression, let's type quantity, and the IntelliSense brings up the sales data table with the quantity sold column. So let's select that and insert the multiplication sign, and let's type related, and let's select the product list table with the cost per unit column and insert the close bracket and hit enter. And we can see our measure here in the calendar table. We didn't select a home table when we created this new measure, so the measure will default to the first table. We can change that here in measure tools. Here under home table, let's select sales data, and our measure moves here to our sales data table. Next, let's select our sales data table here in the fields pane and select new measure. And let's call this measure M margin. So this measure's home table will be the sales data table, and it won't default to the first table. Equals, here we're going to use our sales value measure minus our cost of sales measure. And notice we didn't have to reference any tables. So when you're using measures in your formula, there is no need to specify table names. The reason for this is, as we know, measures don't belong to any tables, and the results are calculated on the fly when we need them. And let's hit enter, and we have our margin here in our sales data column. Let's compare our margin measure to the one in our calculated column. Let's remove the sales value fields here by Xing them out, and let's drag our margin and M margin, and they're the same. Next, let's calculate our margin percentage. We'll follow the same steps. Ensure that your sales data table is selected, click on new measure, and let's call this new measure M margin percentage equals, and we're going to use the divide function, just like we did in our calculated column. Our numerator is our M margin measure. Then insert a comma, and our denominator is our M sales value measure. And hit enter, and we have our margin percentage measure here in our sales data table. Let's compare it to the margin that we calculated in our calculated column. Our calculated column margin is way off from our measure. That's because it's being summarized by default. We can switch this off by clicking on this drop-down arrow here and selecting Don't Summarize. And we can now see the distinct values for this column. You can also change that here in the Data tab. Select the margin percentage column, and here in Column Tools, under Summarization, you can select Don't Summarize. Let's go back to our report view and select our margin percentage measure so that our Measure Tools tab displays. And let's change our format to percentage and our decimals to 0. So our margin percentage measure now displays in the correct format. So to recap, to calculate a measure using columns from a table in our data model, we need to use iterating functions. Iterating functions allows us to use expressions in our formula, and these are the functions with the X. Measures do not belong to a specific table, so when you're using a measure in your formula, you don't need to reference a table. Okay, so now that we understand the difference between a measure, calculated column, filter context, and row context, hopefully this sets the foundation for building your measures. Just one more tip. You may get to a point where you've created lots of measures, so to avoid the frustration of looking for your measures in the various tables, let's create a measure table so that we can organize our measures in this table. Here in the Home tab, click on Enter Data, and Create Table pops up. Let's name this table Measures Table and load it. And we can see it here on the right in our Fields pane. Now let's click on one of our measures And up here in the home table, let's change this to measures table, and our measure has moved. We can do the same for the rest of our measures. So now all our measures are neatly organized and we can find them quite quickly when we need them. Let's delete column 1 from this table as we don't need that. Let's click on this table to select it and delete it so that we can build our visuals for our report. We're going to use the visualizations pane and the fields pane on the right here. The fields pane has our 4 tables, and when we expand each of these tables, we will be able to see our column names for each table. Basically, the fields pane is the same as our data pane in the reports table. Then the visualizations pane is made up of these 2 areas. The top is where you will find your chart types for building your visuals, and the bottom area is the field where the data for your chart will be added. That data is a drag and drop of your column names from the fields pane. To build our first visual, let's click on the stacked bar chart, and an empty bar chart gets added to our report canvas. To add data to this chart, we need our product name and the sales value. So our product name is here in the product list table, so let's drag this to our y-axis. And the sales value for each product is here in our sales data table. But remember, this was a calculated column. The measure for this is here in our measures table. So let's drag the M sales value to our x-axis. And we have our first visual. Next, let's click on the table visual, but notice that our bar chart has now changed. So to avoid this, let's press Ctrl Z to undo. When you want to add a new visual, always click on an empty space so that none of your current charts are selected. Let's click on the table visual again. Notice that the second area in your visualizations pane changes depending on the type of visual that you use. So the bar chart had the Y and X axes, and the table has only the columns field. Let's choose location from our sales data table, and sales value from our measures table, and margin also from our measures table. Remember to click on the empty canvas to deselect your chart, and let's select the donut chart. And for this one, we want location as our legend and our margin as our values. Remember to select an empty area on your canvas, and let's select the area chart. For this chart, we're going to use our calendar table. Let's select our month name, which is for our x-axis, and let's select the margin for our y-axis. We want our months to look like this in our area chart, but right now they're in the incorrect order and we have the full month name. We will get to how to make these changes in a few minutes. Next, let's select this 1, 2, 3 icon, which is the card icon, and let's select the sales value measure, and let's copy this card and paste it here so that we have a duplicate. And this time, let's use margin as the field. Next, let's add a slicer, and we want this to be the year from our calendar table. We get a timeline, but we want this to be a list. We will get to how to change this in a few minutes as well. Let's copy this slicer and paste it here. And for this slicer, we're going to use the product range from our product list table. We have all our visuals. Now let's format them. So we use the Build Visual tab here in the Visualizations pane to create our visuals. And to format our visuals, we're going to use this tab here next to Build Visual called Format Your Visual. First, let's rearrange our visuals. Now that we have our charts more or less where we want them, let's start with formatting our timeline. Click on it to select it, and in the Visualizations pane, click on Format Your Visual, and let's click on Slicer Settings. Under Style, let's click on the drop-down, and the style that we want is the vertical list. And let's resize this. We also don't need the slicer header, so let's switch that off. Next, let's format our sales value card. Let's expand our fields pane on the right here and expand our measures table. And let's click on our M sales value measure so that the measure tools tab displays up here. And under name, let's rename this to total sales. And the category name for our sales value card changes. If you want, you can change the font and color of your text. Here under Visualizations, click on Format Your Visual, and here under Visual, you can change the font and color of your card for the callout value, which is the sales value number that's displayed, and you can also change the font and color of the category label, which is the text under your number. I'm just going to bold the category label for now. Next, with our total sales value card still selected, click on General and Expand Effects, and let's scroll down to Shadow, and let's toggle this on so that we create this depth to our visual. Next, click on Format Painter, and let's format our margin card the same as our sales value card. Next, let's click on our M margin field here in the Fields pane so that our Measure Tools tab displays. And let's change our name to Total Gross Profit, and our margin card updates to show Total Gross Profit. Next, let's click on our Product Range Slicer, and in the Format Your Visual tab, go to Visual and click on Slicer Settings. And under Options, let's change this from a vertical list to a tile. And here under Slicer Header, let's switch this off, as we can see that these are our product ranges. And let's resize our slicer so that we get all 4 tiles horizontally. Next, let's select our bar chart, and in the Format Your Visual tab, under Visuals, let's expand the Y-axis, and here under Title, let's switch this off, as we can see that these are product names. And let's click on the X-axis and switch off Title as well. If you expand values under the X-axis, you can change your display units, but I'm going to leave this as auto for now. Then in the General tab, let's expand Title, and let's change our title to Total Product Sales. Also in the General tab, let's scroll down to Effects and go to Shadow, and let's switch this on so that we create this depth to our visual. And let's select Format Painter and add this shadow to our donut chart and to our table, and lastly to our area chart. Next, let's select our donut chart, and here in Format Your Visual, let's expand Legend, and let's switch off the title of our legend, as we can see that these are our locations. If you want to change the colors on your donut, you can do that here under Slices. But I'm going to leave this as is for now. We also want to change our decimal places to 0. We can do that here in Visuals. Scroll down to Detail Labels, and here under Values, go to Display Units, and let's select thousands. And for the value decimal places, let's change this to 0. And for the percentage decimal places, let's also change this to 0. And our data labels on our donut chart look a lot better. Next, let's select our area chart, and in the General tab, let's go to Title, and let's change the title to Total Gross Profit by Month. Next, in the Visual tab, let's switch off the Y-axis, and all the detail for our Y-axis no longer displays, as when we hover over our chart, we get these tooltips showing our gross margin for each month, and that's sufficient detail for now. Next, let's expand the X-axis and scroll down to Title, and let's switch off our title, as we can see that these are our month names. Now, to get our month names abbreviated and in the correct order, let's go to our data view, and let's select our calendar table and create a new column. And let's call it month equals, and type format. The format function is a text function that allows you to convert a value to text in a format that you specify. For the value, we want the date column, so insert the square bracket, and our IntelliSense brings up the date column, so let's select that and insert a comma. Then in double quotation marks, type MMM, as this is the format that we want our month names, and insert the close bracket, and let's hit enter, and we get our months in this abbreviated format. Let's go back to our report view, and let's click on our area chart, And let's click on the Build Visual tab and expand our Fields pane. Let's remove month name, and instead let's use the month field that we just created, and we get our abbreviated month names. However, the order of our month names is still incorrect. So let's select the month field here in our Fields pane so that the Column Tools tab displays, and let's click on Sort by Column, and let's sort by month number. Our chart still hasn't updated to show the correct order, so let's remove month from our x-axis and let's re-add it, and our chart correctly shows the order of our months. I've realigned our charts and added the margin percentage measure to our table from the Fields pane on the right here. Let's create our chart title. Let's go to the Insert tab and click on Shapes, and let's select this line and let's reposition it at the top here. Next, let's insert a text box and type Miss M's Perfect Pizza Sales Report, and let's select that and bold it, and let's make it a font size of 20. Next, let's click on Image and let's select this pizza image. Next, let's click on the View tab, and here on the left we get these themes, and you can choose whichever theme you prefer. I'm going to choose this dark theme, and we get the dark theme on our report. I'm going to be releasing a video on how to share your Power BI reports and how to use Power Automate to schedule sending out your reports, so please be sure to hit the notification bell so that you know when that video is released. Now that we have our report set up, we can answer the questions set out in the beginning of this video. The year that had the highest profit margin, 2020 had $1 million, 2021 had $2 million, and 2022 $1 million. So it's safe to say that 2021 had the highest profit margin. The pizza with the highest sales value in all 3 years is definitely the Tutto. The location with the highest profit margin percentage over the 3 years was London with 53%. Then the report that can be used on an ongoing basis to analyze the sales data is the sales report that we've now created.